Welcome back. Today we're going to talk about writing linear functions. Okay, so throughout the lesson for today we're going to be given bits of information and we're going to use that information to write functions in slope-intercept form. So the easiest bit of information that you could get is just being given the slope and the y-intercept, right? This is a fairly easy situation here where it's saying write a linear function f of x that has a slope of 3 and a y-intercept of -1. Well, we can just translate that very easily into the slope-intercept form. So it's going to be 3x, and we're going to do -1. We could do a plus -1, but it's a little bit more simplified to do -1. Okay, so there we go. We wrote the equation in slope-intercept form that has a slope of 3 and a y-intercept of -1. Okay, if you have been given information in a table, so remember what we need. There's two things that we need to write an equation in slope-intercept form. We need the slope and we need the y-intercept. Okay. Now, what we can do, it's a little harder to do this in a table. Sometimes the table will give you a value of, let's say that they give you a value of 0 for x, and they actually give you a value of f of x when x is 0. That, if they do that, that's sort of a perfect situation because they've already given you the y-intercept. So for instance, if this table included a value that was like, let's say it was 0, 1, then I could pick off this 1 right there and say, there, that's the y-intercept right there. But it didn't do that, so we're a little bit out of luck. We're going to have to go do a longer method. Okay, so the step number 1 is you want to find the slope. Okay, and to find the slope, just pick off 2 of the points in the graph. So remember, these are x, y coordinates because f of x is equal to y. Okay, so let's pick off some 2 points. Let's write them vertically. -1, 5, and 3, -3. Okay, let's go through the formula. Slope is equal to y2 minus y1 over x2 minus x1. Okay, and so we have 5 minus -3, and we have -1 minus 3, which gets me 8 over -4, which is -2. Okay, so my slope is equal to -2. Now, I have my slope, but I don't have my y-intercept. So, and those are the 2 things I need, right? Because the slope-intercept form takes y is equal to slope times the x plus the y-intercept. So I just need to be able to fill in these 2 blanks here. And I have my slope, so I can sort of already do this. Y is equal to -2x plus, but I don't have my y-intercept, so I have like a b there. Well, here's the trick. What you're going to do is you're going to temporarily borrow one of these points. It doesn't matter which point. Okay, I'm just going to choose the one in the middle. It doesn't really matter which one. And I'm going to put this value in here for y rather. So I'm going to put -3 in for y, and I'm going to put 3 in for x. And I'm going to pretend that I have everything in this equation except for my b, right? So I have -3 is equal to -2 times 3 plus b. Well, when I have an equation with only one unknown, it's very easy for me to solve for that unknown, right? So here I have -3 is equal to -6 plus b. I add 6 to both sides, and I have b is equal to 3, right? So right there, I solved for my y-intercept. So I have the slope, and I have the y-intercept. So now that I have the y-intercept, I'm going to disregard the point that I used before. I don't need that point anymore. That point only helped me find the b. Now I want to write the solution to all of these. I want to write the equation, which is going to be an infinite number. It's going to have an infinite number of solutions. So I don't care about the one solution, which was 3, -3 anymore. I don't want that anymore. That just was helpful for a little while. So I'm just going to rewrite the equation with the slope here and the y-intercept. Okay, so here I found the slope using the 2 points from the table. Then I used the slope and 1 point from the table to find the y-intercept, and I use both of those pieces of information and I put that in to make the general form of the equation, or sorry, the slope-intercept form of the equation like this. So the answer to my question is y is equal to -2x plus 3, or you could write it in f of x notation, which is f of x is equal to -2x plus 3. Okay, so that's a very quick way of finding the equation given a table. All right, but just be aware of the fact that, first of all, you can use any 2 points in the table. If there are points that you like from the table, then choose the points that you like from the points that you want to find the slope from. And then after you find the slope, choose any of the points in the table to use to plug your x value and your y value in. So this was my x value, this was my y value, in, and then solve for b. Once you have b and the slope, the m, you can put that all into the equation together. You don't need the point that you used anymore. Okay, never leave, a common mistake is to actually leave the point in the equation. So sometimes I see students do this. They'll say, so the point that I used up here was 3, -3. So they'll say, oh, -3 is equal to -2 times 3 plus 3. In other words, they'll put the 1 point that you used in order to find the b, they'll leave that into the equation. And while this is true, -3 is equal to -6 plus 3, right? This is a true statement. All that's doing is that's confirming the point 3, -3 is a solution to the equation y is equal to -2x plus 3. It doesn't give you any more information. Whereas if you leave x and y in as variables, what you're saying here is that there's an infinite amount of solutions to this equation. You're looking for solutions such that y is always equal to x times -2 plus 3. So this is standing in for an infinite amount of solutions, whereas this right here is only indicating one solution. All right, so theoretically, it's a really big mistake to keep that point in and to not use the b that you found to put into the slope-intercept form of the equation. Okay, so you can. This is a situation where you're given a graph and you have to find the equation given the graph. So this is the word problem where the graph below shows the increase in pressure. So the pressure is labeled along the y-axis. It's measured in pounds per square inch as a scuba diver descends from a depth of 10 feet to a depth of 30 feet. So it goes from 10 feet to 30 feet. So it looks like he's, the pressure is in, so as the depth increases, the pressure is also increasing, right? It's a positive slope here. Pressure is a linear function of depth, meaning that it's every time you decrease your depth by a little bit, or you increase the depth you are below the water, the pressure increases by the same rate for each amount of depth you increase. So at the water surface, the pressure on the diver is a result of the pressure of the air in the atmosphere. What is the pressure on the diver at the water surface? So what they're looking for is at a depth of 0, what is the pressure for the diver? Well, in order to do that, we're going to have to figure out the equation for this line and then figure out what the pressure is when the depth is 0. Okay, so we're looking for the equation. Now, fortunately, they've actually given us 2 points. They've written down the 2 points on the graph here. Otherwise, you can just take the points on the graph, write down the points, and then use them to find the slope. The first thing that we want to find is the slope. When we find the equation, the first thing that we always want to find is the slope. Okay, so here I want to do 28 minus 19.1 over, let's see, 30 minus 10, okay? So 28.0 minus 19.1, see here. That would be 18, but we're going to reduce it to 17, and that's 1 here. So this is 9 and 8. So it's going to be 8.9, okay? So 8.9 over 20, okay? So let's see. So we want to divide, let's see, 8.9 divided by 20 is the same as, so it'd be 8, oh no, that would be 4. 4, that would be 8, 1, bring down this, that would be 44.5, except we're dividing by 20, so we actually have to bring this over by 1, or we have to reduce the power of 10 here, so it'll be 0.445 here, okay? So your equation is going to be, the slope of the equation is going to be 0.445. 5. And that's going to be in pounds per square inch per foot. Let's see. Yeah, because it's rise over run. So you use the units in the rise, which is pounds per square inch, which is a measurement of pressure over the amount of feet. So it looks like it's the pressure is increasing at a rate of 0.445 pounds per square inch for every foot in that they descend in the water. Okay. But this hasn't answered our question yet, because the question is, what is the pressure on the diver at the water surface? So we just found the slope. In order to find the y-intercept, what we're going to have to do is that trick that we showed you before, which is take one of the points. I'm going to take this top point up here. And I am going to put it into the equation here. So this is my x, this is my y. So I have 28 is equal to 0.445 times 30 plus b. So let's see, 445 times 3. Well, that would be 13, carry the 1, 12, 13. And I move 3 decimal places over 1, 2, 3. So this is going to be, except I multiplied by 30, so I actually am going to go 1 over this way. Okay, so it's going to be 13.35 plus b. So 13.35 is equal to 28, and I solve this by subtracting. Okay, so b is equal to, so 28.00 minus 13.355. Okay, that would be 10 and 9 and 7. So b is equal to 14.65. Okay, so my final equation is, this is P of D, right? The pressure based on as a function of depth is equal to 0.445, and it's going to be feet plus 14.65. So in other words, the initial value here is 14.65, and if we extend this line so it reaches the y-intercept, so it reaches the y-axis, we would see that it would hit about here, which is 14.65. So to answer this question is, what is the original pressure at the water surface? It would be 14.65 pounds per square inch. Okay, and this is the equation right here. So we did the same thing. This would be in time. We did the same thing that we've done before, which is we found the slope and we used the slope and one of the points to find the y-intercept. And finally, we rewrote the entire thing, given the general, P of D and T here, right? And so we've covered how to write an equation from just giving the slope and the y-intercept, how to write an equation from a table, and how to write an equation from a graph. And finally, we went over a word problem where we talked about the real life value of the y-intercept as pressure at the surface of the water, right? And that's the end of the lesson for today.